In this activity, we're going to take a phrase that is written, a verbal phrase, and change it into an algebraic expression. In this case, these algebraic expressions are inequalities. And so the challenge is to try to get the words, understand the words like not more than, and how that becomes an algebraic inequality. So I'm going to actually just write the 5. 5 is not more than, so we'd say it's less than x. So if we just do it left to right, 5 is not more than, this is the part we have to figure out the inequality symbol that we want to use. So in this case it's the less than because it's not more than, it would be less than. And the real question is, could it be equal to as well? So I would actually, to determine that, I would say 5 is not more than 5. If that's the case, 5 is not more than 5, that's true. 5 is not more than 5, it is 5. Then I would include the equal symbol underneath it. So because 5 is not more than 5, 5 is equal to 5, or 5 is less than x. So whatever x is, 5 has to be less than x as well. And if I wanted to flip that around the other way and think of it this way, x is greater than or equal to 5. So you think of this as numbers that are greater than 5. So if I'd said x is 10, 5 is definitely not more than 10. 5 is definitely not more than 100. So that means x has to be a value greater than or equal to 5. And so that's what you do with phrases. You have to think about the phrase. Sometimes they're pretty straightforward. Like in this case, it just, if I go left to right, x is greater than or equal to, so I have the combination of greater than or equal to, and then the 14. So I can just simply put that in as it's spoken left to right. Or in this case, x is greater than or equal to, so again I have the phrase that gives me the symbol greater than or equal to, so there's the greater than equal to 12. It becomes a little bit more of a challenge when we have things like not less than, which is just really the same as greater than. So 6 is not less than, so that means it would have to be greater than x. Now again, the question is, could it be equal to? So if I were to stick the 6 in for x, if I said 6 is not less than 6, that's true. 6 is equal to 6. It's not less than 6, it's not more than 6, it's equal to 6. So again, this is one where 6 is greater than or equal to x, and I could flip that around and say x is then less than or equal to 6. So I can think of now that the values for x have to be less than 6 or equal to 6. So if I said x is 5, 6 is not less than 5. If x was 2, 6 is not less than 2. So you can see the values of x have to be less than or equal to 6, because I could actually use the number 6 in here. 6 is not less than 6. That is true. And so that's what we do as we continue through these. Sometimes, again, they're pretty straightforward. The value of x is greater than 7. So x is greater than 7. Just have to write it out as it's spoken. Same thing with this one. X is greater than, so I get the symbol greater than 15. X is greater than 15. Now here again we have a not more than. So that not more than means less than. So x is less than 13. Now the question is, could it be equal to 13? So I just put the number 13 in the phrase in place of x, and I say 13 is not more than 13. And that's true. 13 is not more than 13. So I put the equal sign in there as well. So less than or equal to 13. 13 could be an answer to this, because 13 is not more than 13. And again, another fairly straightforward one. 9 is less than or equal to, so we just have it pretty straightforward. X, and again, if I want to flip that around to have the x on the left side, I have to flip the sign with it. X is greater than or equal to 9. So anytime I flip this over from one side to the other, it's like your hand, it flips over, the thumb goes with it, and the sign goes with it in these as well. Let's do a few more examples. So here we have at least. So x is at least 1. So that means x has to be greater than or equal to 1. If it's at least 1, see 1 is at least 1. The value of 1 is at least 1. So that's why we have the equal sign in there as well. It's greater than or equal to 1. If I pick 10, 10 is at least 1. If I picked a million is at least 1. If I picked 1, 1 is at least 1. So there's where the equal sign comes in on that one. The value of x is less than 14, so straightforward. X is less than 14. Pretty clear. X is less than or equal to, it gives it to me straightforward there, 10. X is more than 3, so x is greater than 3. More than would be greater than. 16 is less than x. That means x is greater than 16 if I flip it around the other way. So at most, when we think of this term, x is at most 18. So the biggest it can be is 18, which means it has to be x is less than or equal to 8, because it can still be 8. 8 is at most 8, if you put the 8 in for x. We think of 8 is equal to 8, anything less than that. So if I said x is 5, 5 is at most 8. We haven't reached the at most, so anything below it would be included in the set of answers. And then the value of x is not greater than, so which would be the opposite of greater than, less than. So not greater than gives me a less than. So the value of x is less than 18. Now the question is, could the answer also be 18? So is 18 not greater than 18? Yes, it is. So because 18 is not greater than 18, I need to put the line underneath there to show that 18 could be an answer. It's equal to or less than. If something is not greater than, it can be equal to it or it can be less than. And then the last example here, 2 is more than x. 2 is greater than x. Or I could say x is less than 2. And so that's how you translate phrases into algebraic expressions that are in inequality forms.